Hello. Okay, interfaces. As promised, interfaces are abstract classes that are even more abstract than an abstract class. They are as abstract as they could possibly be. They can't contain instance variables. They can't contain non-abstract methods. So the word interface comes from the fact that they just define method headers, the interface part of the method. Okay, so let's take a look at the guide here, section 3. You create an interface by creating a class, but you use the keyword interface in the class header instead of the word class. So you say it's an interface. All of their methods have to be abstract. This says instance variables, but this shouldn't say instance variables. They can't have instance variables. They can have static, public, and final variables. They can define constants that are given a value when they're declared. So you can have constants, but you cannot have any other type of variable. You can have static constants. Subclasses don't extend interfaces, they implement them. And it's shown as a dotted arrow. So here's a UML diagram, class diagram from a textbook that I used to use that we don't use anymore, but I think this is a very nice example. So what it's showing here is, and you can see in some cases the classes are just shown as names. You don't see their instance variables or their methods because we're just focusing on the relationship. This here is an abstract class with an abstract method, and this here is an interface. And there's no real way to show the difference between an interface and an abstract class except by putting this little notation interface on it with the angle brackets. So that's how we show it in a class diagram. You can see now every class can only extend one other class. So orange and apple extend fruit. Chicken extends animal. Tiger extends animal. But fruit and chicken are edible. And so they implement this interface edible. Now notice this arrow is a dotted arrow, but otherwise it looks like an inheritance arrow because it sets up an is-a relationship as well. A chicken is an edible, a fruit is an edible, a chicken is also an animal, and a tiger is an animal. So if we have a chicken object, let's use apple. If we have an let's use chicken. If we have a chicken object, we can store it in a variable of type edible because it implements that interface, which means it has these abstract methods in it. Or we can store it in a variable of type animal, which is an abstract class. Or we can store it in a variable of type chicken. Okay, so the declaration line for chicken looks like this. Public class chicken extends animal and implements edible. So it's got two is's. It's an animal and it's also an edible. But we say implements here because edible is an interface. Let's take a look at this code in action here. I'm going to take this circle, rectangle, etc. code and put it back into week 9 code. And I'm going to grab the relevant code from this example. So it's animal, apple, chicken, edible, fruit, orange, test edible, and tiger, I think. I'm going to move all of those over here. Refactor. So here are my things. Let's take a look at the chicken class to start with. This is not my original code. This is by the author of that textbook. But like I said, I think it's a nice example. So chicken extends animal and implements edible. So animal is an abstract class that contains an abstract method called sound. So animals make a sound, and this just returns a string that tells you what sound they make. So it's overridden here. So chicken says cock-a-doodle-doo. That's what it returns. And then edible is an interface. See here, public interface edible, which contains a string class, which has to be abstract, called how to eat. Okay, and the difference between an interface and an abstract class is this. See, I cannot interface abstract methods cannot have a body, so I can't put a body on an interface method. Actually, it turns out I don't actually have to say abstract. I think that might be a new feature. Because it's an interface, it's assumed to be abstract. You don't actually have to say it, but you can if you want. I think maybe you don't have to say public either. I think it's public by default, but we'll leave those in for clarity. The animal class, on the other hand, because it's abstract, if I had wanted to, I could actually, define a body on this. It's not an error to do that. And I can have other methods in here, public int foo return 0. So I can have methods with bodies in here because it's an abstract class, and I can have instance variables and stuff like this. I can go, public or private int x equals 5. Okay, so that's the difference between an abstract class and an interface. I can implement some of the class here, but for the interface I cannot. Okay, so it's an animal and it's an edible. Because it's an edible, the chicken object has to implement how to eat, which returns fry it. All right, if we take a look at the orange class, orange extends fruit, but for some reason it still has to implement how to eat. Why? Because fruit implements edible and is abstract. So if we go back to the diagram over here, fruit is in italics here. This is an abstract class. Again, fruit is too generic to implement, right? You need to know what kind of a fruit something is before you can set its properties. Is it an orange? Is it an apple? Is it a banana? If you just say, I want a fruit, we're going to have to pick one of those things. We can't just hand you a generic fruit. Doesn't make any sense. Right, so it's abstract as well, and it implements that class. Because it's abstract, it doesn't have to implement the method in edible. It doesn't have to implement that method because it's abstract. If I take that away, I'll get an error saying it has to implement how to eat, but without it, it doesn't have to. But it's anything that subclasses off of it, which is not abstract, like orange, which extends fruit, has to implement that method. Because fruit's not an animal and orange is not an animal, it doesn't have to implement the animal sound that it makes method. Okay, so that's the orange and the fruit class. And then what I would like to do actually is I would like to extend this drawing a little bit, because what I want to show you is what interfaces get us. They get us a bunch of things, and they're used actually all over the place in Java. What they get us is a form of multiple inheritance. So in Java, there's a rule that says that you can only extend one class. A chicken can be an animal, but it can't also be of another class. You can't do two extends on chicken. Some languages allow that. Python, I know you didn't do object-oriented in Python, but it allows multiple inheritance. Multiple inheritance does create certain issues, like if you're extending two different classes and they both have the same method, which one do you inherit? Which class do you inherit the method from? So there's ways around that, and Python solves that problem. But the other way around it is just to not allow multiple inheritance, which is the direction that Java goes. But you can have, the interface relationship and the implements relationship gives you a type of something like multiple inheritance, because now I can say that a chicken is an edible and is also an animal. It's only extending animal, but it's implementing edible. So I've got two inheritance-like arrows coming off of it. And with interfaces, because there's no question about which method do you inherit, because if you implement two interfaces and they both have the method with the same name in them, it doesn't matter, because neither one is implemented anyway. You just have to implement one of them in your class. So because of that, I can actually have multiple interfaces that I implement in a class. So to show that, what I want to do is create a new interface called buyable. So things that you can buy, right? You can buy fruit, you can buy chickens, but you can't buy tigers, let's say. I mean, I know you can probably buy tigers, but you shouldn't. They're endangered. And you shouldn't be keeping a tiger. Wherever you are, I'm going to say you probably shouldn't have a tiger in your house. Whether you're in a country that normally has tigers or whether you're in a country that does not normally have tigers and has to import them. Okay, that's my environmentalist intervention for the day. So I'm going to create a new interface here. You'll notice there's no interface option here. You say Java class, and then it gives you the interface option. I want this to be an interface. Or you can just change it, write it from scratch yourself. It doesn't really matter. So buyable is going to be my new interface. So it's public interface buyable. And I'm going to have a get price method. So public static, no, not static, public abstract get price, semicolon. This is going to be a double. Okay, so if something implements the buyable interface, they will have to have a method that returns the price of the object. And they can do that any way they want. They can do it with a calculation, they can hard code a number, they can have an instance variable that stores that number and returns it. It's up to them. Okay, now fruit are going to be buyable. So they're going to implement edible and buyable. And when we do that, we'll start to see some problems crop up because we have two fruits, orange and apple, which now have errors on them saying this either has to be abstract or you're going to have to implement get price because they extend fruit and fruit implements buyable and buyable requires them to have that get price method. So we'll just have to come up with a price for an apple. Public double get price return, I don't know, 99 cents for an apple. Okay, now we're okay. And we can add the override tag if we want to be clear on that. And then we could copy this and put it in orange as well, like that. But oranges are, let's say, cheaper. Let's say they're 25 cents. All right, so now all the fruit, abstract class fruit implements two interfaces now. Each one of them has a method in it that needs to be implemented. By the way, you can have more than one method in an interface. So the Bible interface could also have like public, abstract, double, what else? How about get wholesale price? So that's the price that they would charge to grocery stores and stuff. So now we have two methods that we have to implement. Should pop up an error. Yeah, it didn't immediately pop up an error, but here it is. We now have to implement the abstract method get wholesale price. Alt enter, implement the method, go for it, and it'll make a stub for me here. So I can put whatever I want in there. And then Apple over here is going to need to do the same thing. Alt enter, implement method. And we'll say that Apple's wholesale are 50 cents and retail for 99 cents. Okay. We were going to do the same thing with chicken as well. So chicken is going to have now three kind of superclasses above it. It's going to extend animal, it's going to implement edible, and it's also going to implement buyable because you can buy a chicken. And now it's got errors because we need to implement the methods, and we can implement them both at once. There they are, get price. Let's say a chicken is $10.99, and let's say that's what it retails for, and it wholesales for $5. Okay, all done. Now, if we were going to add that to our UML class diagram over here, we would have another interface out here, and we would have dotted arrows coming off of fruit and chicken with diamond arrowheads here going to the other interface over here. Okay. If you want to make abstract stuff in Umlet, if you're using Draw.io or Visio, it's probably fairly straightforward. But here is here's an example class here. If I click here, you can see it's already got a little annotation up there. So we can just change that to interface. And then here, let's create our interface here, buyable, like that. We want the whole thing to be in italics, so we want the name to be in italics. So we put slashes around it and it becomes in italics. It's not going to have any instance variables, but it's going to have two public methods. One is get price, like that, double, and the other one is get wholesale price, which is also a double. And we want these to be in italics, so we put slashes around them like that to show that they're... oops, I think I deleted... there we go, that's what we need. Okay, so there's our interface there. And if we want to show the picture here, fruit, orange, and apple, let's just put those in there. Where are we? Here we are. We can use a simple class here. So fruit is going to be here. Orange, apple, like this. Let me just change this to fruit, which is actually an abstract class, so we put it in italics. Apple and orange. like that. We have an inheritance relationship between orange and fruit and apple and fruit. If you double click an item in Umlet, it just changes it like that. And right here, it duplicates it like that. And right here is the implements arrow. So we would use this arrow with the dotted line. It looks like an inheritance arrow, but it has a dotted line to show that it implements the Bible interface. And that's it. So that's I just wanted to show you how you create these things in Umlet. So if we were going to recreate this drawing, we would need a lot more classes and interfaces added here, but that's the one that we just created. Okay. Yeah, that's it. There is a fourth optional section here on the comparable interface, which is cool, but I'm not going to say anything more about it. You can take a look at it if you want. It's sort of previewing a topic that will come up in data structures in 4th semester, which is cool, but we don't need to talk about it here if you already have your hands full with the rest of the stuff. If we go over to exercises here, part 3 has an exercise to do something similar to what I just did. So I want you to expand the edible example, so using the code that's already there. And you can see that we have a new catchable interface, and we have a new animal. So I want you to implement all of these relationships, all of these I want you to implement all of these implements relationships and inheritance relationships if necessary. I think it's just new implements ones. So it's not that much to do, but I just wanted you to get a little bit of practice with an interface. There's another exercise here as well for graphics, for geometric objects, which is kind of cool and kind of a preview of what you're going to be doing in the assignment as well. So you could take a look at that one too. But other than that, we'll take a look at them in the live class, and I will see you there. Yeah, there's one more video to watch, which is for the assignment, but it'll be a short one, and I'll see you in class.